Separation of heterogeneous mixtures. Heterogeneous mixtures can be separated into their respective components by simple physical methods such as handpicking, filtration, sieving. Generally, following physical properties are considered in the separation of constituents of the mixture. The constituents can be separated on the basis of densities of the constituents of the mixture. Can be separated on the basis of melting points and boiling points of the constituents of the mixture. Mixture can also be separated on the basis of melting points and boiling points of the constituents of the mixture. The property of volatility of one or more constituents of the mixture that can also be used in separation of components. On the basis of solubility of the constituents of the mixture in different solvents. The next property is ability of the constituents of mixture to sublime, that is on the basis of sublimation. And last one is ability of the constituents of the mixture to diffuse, that is diffusion property. It must be noted that for separating homogeneous mixtures, special techniques are used depending upon the difference in one or more physical properties of constituents of the mixture. Now, techniques used for separating the components of a mixture. The first is separation of a mixture of two solids. The method used is by sublimation. The changing of solid directly into vapor on heating and of vapor into directly solid on cooling is known as sublimation. Now the separation of mixture of solids. This method is used in separation of such solid-solid mixtures when one of the components sublimes on heating. However, it is useful only if the components of the mixture do not react chemically on heating. Following are the examples of mixtures which can be separated by the process of sublimation. We have a table of examples of solid-solid mixture and the solid which is sublimable. The mixture of common salt and ammonium chloride, the sublimable solid is ammonium chloride, and a mixture of sand and iodine is a sublimable solid. Common salt and iodine is sublimable solid. Sodium sulfate and benzoic acid undergoes sublimation, and in a mixture of iron fillings and naphthalene shows sublimation. Now method. In the separation process, place the mixture of common salt and ammonium chloride in a china dish and heat it over a low Bunsen flame. A clean glass funnel in an inverted position in china dish should be placed and close the mouth of its stem with a cotton wool. Here the ammonium chloride in the mixture sublimes to form dense white fumes. These fumes condense on the cooler sides of the funnel in the form of fine white powder. When the mixture gives off no more white fumes, lift the funnel, scrape the fine white powder from its sides on a piece of paper. This is pure ammonium chloride. The residue left behind in the funnel is sodium chloride. In this way, these two are separated. Here in the diagram, we can see it. We have placed the mixture of common salt and ammonium chloride in a china dish as shown here, and it is heated over a low Bunsen flame. When this process is done, it must be covered with clean glass funnel in inverted position in china dish, and its mouth should be closed with cotton wool. On heating, here ammonium chloride in the mixture is undergoing sublimation to form white dense fumes, as we can see it with brown color. These fumes condenses on cooler sides of the funnel in the form of fine white powder. When the mixture stops giving further white fumes, then funnel is lifted. Fine white powder is scraped from its sides on a piece of paper. This is pure ammonium chloride obtained. The residue left in the funnel is sodium chloride. In this way, these two substances which form mixture are separated. So more examples of substances undergoing sublimation are dry ice, that is solid carbon dioxide, and anthracene,